So we're just going to graph one period. What would the helper function be here?
Y equals 3 halves cotangent of 2x.
So y equals 3 halves cotangent 2x. Just delete the minus pi halves for the time being. Okay, so that's what we're going to graph. And if you watch the video, then you know how to graph this thing. I'm going to graph just a single period of a cotangent function and adjust the scaling appropriately. So same story, different function. There are two asymptotes associated with the, well, there's an infinite number of asymptotes that go with the cotangent, but we're going to focus on two of them. The left-hand one is going to be the y-axis itself. What's the equation of the y-axis? Everybody should know that the equation of a vertical line is x equals whatever its horizontal position is. So the horizontal position of the y-axis is 0. It's at 0, x equals 0. So x equals 0 is the equation of that vertical line that is the y-axis. And then what's the normal period of the cotangent? Pi. So how would you get the period of this guy?
Multiply it by 2.
It would not multiply, but divide. So you would take pi. The normal period of the cotangent is pi, and you would divide it by this number. It's the same technique, or multiply by 1/2. It's the same technique we use to get the period of the sine and cosine, except the normal period of the cotangent is pi, so we use pi instead of 2 pi on top, and divide by whatever the factor is in front of the x. Okay? So pi halves. So the distance between the asymptotes will be the period. And in this case, it'll be pi halves. So the right-hand asymptote will be this sort of vertical line. I'll just pick a distance.
Do you graph this like a cubed function, like x to the 3rd power?
There are some similarities between the tangent graph and the cubic, but no, they're not the same curve. So this vertical line would be x equals, since we're judging the distance from an x horizontal position of 0, that distance is pi halves. So this vertical line must be at a horizontal position of pi halves. And you can make that dashed if you want. If you don't have different colors, make that asymptote dashed. So the y-axis is an asymptote. X equals pi over 2 is an asymptote. The one period that you're graphing, or any period, will not cross the asymptotes, right? And then it turns out that you're going to plot 3 x values, the one in the middle, between the two asymptotes, the one halfway between the middle and the right asymptote, and the scale marker x value halfway between the left-hand asymptote and the middle mark there. So 1, 2, 3, 4. Once again, we're breaking this up into 4 subintervals in between the asymptotes.
This one's for the helper function, right?
We always graph the helper function first, correct? Yeah. So you could either memorize this or figure it out. The cotangent is going to go through here. How do you figure that out? Plot it. What does this x value have to be right here? Well, if this is pi over 4 right here, what does this x value have to be? I'm sorry, I gave it away. If this is pi halves right here, what does this x value have to be? Pi fourths. Darn it, I hate it when I do that. When I'm tired, I do that. I think ahead and then give away answers. And then what would this value have to be halfway between 0 and pi fourths? Must be pi eighths. And then this value right here would be the average between pi fourths and pi halves, which would be 3 pi eighths, actually. And if you plug in pi fourths into the helper function, if you plug in pi fourths right here, what do you end up taking the cotangent of?
Pi halves.
You end up taking the cotangent of pi halves. And you might have it memorized or just be able to derive it. The cotangent of pi halves is 0, right? So you know that point's there. Either you memorize it or you can figure it out. And then it turns out when you plug in pi eighths, the cotangent of 2 times pi eighths, if you think about it, the cotangent of 2 times pi eighths is the cotangent of pi fourths, and the cotangent of pi fourths, same as the tangent of pi fourths, is equal to 1. But if you have a 3 halves in front, you get 1 times 3 halves. Oh, so it's 3 halves. So whatever this mark happens to be, it depends on the period, it'll always go up to a height value corresponding to this, at least, well, that number in front, or it could be if it's negative in front, it would go down to that.
So if it was like -2 right there, it would be, you'd have one value be 2 for that.
So let me finish the thought. 3 halves, pi eighths, 3 halves. And then if you plug in 3 pi eighths, you'll end up taking the cotangent of negative pi fourths, which goes to -1. And then if you multiply that times 3 halves, you'll get, when you plug in 3 pi over 8, you'll get -3 halves. So you could either just plot these values. In other words, when I say these values, I mean you plot, this is the 1/4 mark, this is the 1/2 mark, this is the 3/4 mark. You could actually plot those values. Whatever they are, for instance, when you plug in the 1/4 mark, you're always going to end up taking the cotangent of pi fourths, which will be 1. And so you'll get whatever the number is out in front for your output. And then the opposite of that number whenever you plug in 3 pi over 8. And it'll work out that way every time. It's easier just to remember the positioning of those 3 points, and then, what does the graph look like? It looks something like this. It has this kind of wiggle in the middle. And then as it goes to the left, it approaches the asymptote, the left-hand asymptote, and shoots upward. As it goes to the right, it approaches the right-hand asymptote and shoots downward. And that's the helper function, by the way. That's not the final graph. So then what do we have to do? We have to figure out the shift. What kind of shift will it be? Since we're subtracting something from an x value, 2x value, it's going to be a horizontal or phase shift, right? And how do we find that phase shift? We're going to set this guy equal to 0. So we set that guy equal to 0. So this is for the phase shift, PS. 2x minus pi halves equals 0. What do you get if you solve that for x? So you add pi halves, multiply by 1/2 to isolate the x. You get x equals pi fourths. Does everybody agree with that? So it's positive, so the phase shift is right pi fourths. Everybody agree with that? Any questions on that? So the scaling's easy. We know the distance that represents pi fourths in the graph. It's this distance right here in yellow. We have to move everything to the right, that distance in yellow, right? That includes the asymptotes, doesn't it? So the left-hand asymptote, the y-axis asymptote, moves to pi fourths. So it becomes x equals pi fourths. So I'll do that one in purple. So this y-axis asymptote is going to, and I'll make it longer so that we can focus our eyes on it. So that y-axis asymptote is going to move to the right pi fourths. What's the equation of it? X equals pi fourths, the horizontal position. You should be able to come up with that equation if you're asked. And then this asymptote in green right here, which was at x equals pi halves, where's that going to move to? So it's got to be that distance in yellow. I'm just eyeballing it approximately there. And what will that value be?
Pi halves.
So it would be pi halves. It would be pi halves plus pi fourths was the distance we moved it, right? So what would that be? So this would be, pi halves would be 2 pi force, right? If you multiply by 2 over 2. So how about 3 pi force? Would you buy that? Okay. So I'm going to make another purple asymptotes. And the purple asymptotes are going to be all that matters for the final graph. And what would the equation of that purple asymptote be? So x equals 3 pi over 4. And then we'll just move all those 3 points that we plotted, we'll just move all those to the right. The final graph will be in blue. So this guy moves over here. This guy right here moves to here. This guy moves to where the green asymptote was. This x-intercept moves to where the green asymptote is. Then this guy moves pi force over here.
The y value for these, and that's it.
So the graph in blue is the final graph. What if I asked you for the coordinates of this point? Could you come up with those coordinates? That's a skill you should be able to have in your repertoire. How would you come up with that point? Well, I mean, it's this point moved to the right pi force, right? Does the height change? Okay, so where was that point at? What are the coordinates of this point? 3 pi 8, comma, negative 3 halves, right? That was on the graph in orange. So what would the corresponding point be after you move it to the right pi force? So 3 pi over 8, you would take 3 pi over 8 and add in the phase shift, pi force, and get the common denominator. Pi force is 2 pi over 8, right? Because 1/4 is 2 over 8, isn't it? So you get 3 pi over 8 plus 2 pi over 8, 5 pi over 8. So that this point right here, if I asked you for it, would be 5 pi 8, comma, the height didn't change, negative 3 halves. Does everybody agree with that?